Question number 1, again, is something more from grade 9. It's not something that we really learned in this course. It's not something that we're going to try to test, but it's a kind of question that comes up all the time throughout the course as part of a bigger question. So ultimately, how you solve a question like any kind of equation is you want to get letters on one side and numbers on the other side. Letters equals numbers. And whatever you do to one side of an equation, you have to do the same to the other to keep it balanced. We know all of that. So I want to move things from one side to the other side using the right steps, simplify, and then you usually have to divide in the end. So what would I have to move? Well, if I want to get the letters to the left, I have to get rid of the 2x on the right. If I subtract 2x on the right, I have to subtract 2x on the left. And if I want to get rid of the 4, I'm going to subtract it. And so I'll subtract it on both sides so that I keep everything balanced. Look carefully. These have to be opposite signs. This is a simple question because everything's positive. When there's a negative value, people make mistakes because they have something like they have -5 and they think they're subtracting it. But that gives you 10, so it doesn't eliminate anything. These eliminate because they're opposite signs. So they always have to be opposite. And then those are gone and those are going to be gone, right? So I get 8x. You don't have to write this step, but I'm going to write it. Minus 2x equals 16 minus 4, which is 6x equals 12. And then what do? I divide both sides by whatever's left. And it's amazing that people are so good at this. But then for whatever reason, in a question that's like a linear system, they forget this last little step. They forget what to do to divide by 6, right? So that's something that you're probably good at. So practice a couple of those simple ones, maybe just to make sure you can do it. It's a skill that comes up over and over and over and over again. Go back to basics and how to solve it. How would you solve this one? You would just, so I'm not going to do the whole thing, but you would just expand the brackets first. What I would do is collect like terms on both sides, and then you end up with a question that looks a lot like that, and you just solve it. I'll do it and post a solution online, but I don't think we need to take time to go through it right now. I want to give you some time to practice. Now, solving an equation with fractions, this is one that we really did practice and we really did work at. There are questions like this on the exam, so you want to make sure you know how to do it. They're long questions, so they're worth lots of marks. What's the general idea of how you solve an equation with fractions? Who thinks they have some idea of how to do it? Who thinks they have no idea, they don't remember doing this ever, they don't believe me that we ever learned this? Yeah, nobody put their hand up, that's good. Brianna, what's our starting point? Yeah, we want to get rid of the denominators. Because, go with your gut. You hate fractions, let's get rid of them. How do I do that? Multiply everything by all the denominators. You can think of it as multiplying by 10, 2 times 5, but it's easier to do this. So I'm going to have x over 2, and I'm going to multiply that by 5 and by 2. Okay? And then plus 5 times 2 times x minus 1 over 5. So I multiply everything by 5 and 2, right? And then what about the 12? It's not a fraction. So a lot of people think they don't have to because it's fine the way it is. But no, we have to keep things balanced. If I'm multiplying the left side by 5 and 2, I have to multiply the right side by 5 and 2 as well. So you multiply everything, every number, every constant, every fraction by the same thing. Some people would only multiply this one by 2 and this one by 5 because that's what gets rid of it. But you can't pick and choose. The thing we're doing here is we're multiplying both sides of the equation by 10. So you have to multiply everything by the same number. We're just doing it in a way that's easy to then go ahead and do this. Those are gone, and those are gone. So this ends up being 5 times x. This is 2 times x minus 1. 5 times 2 times, which is 10 times 12 is 120. Use your calculator for that. And again, I'm left with a relatively simple equation to solve. So 5x plus 2 times x is 2x. And then 2 times negative 1 is negative 2 equals 120. I want to add the 5x and the 2x together, so I get 7x minus 2 is 120. Add, this is what I'm talking about. Add 2 to both sides. So look, those have opposite signs, and they will cancel. Okay, and then I get 7x equals 122, and I hope that is going to work. 122 divided by 7, it doesn't. So I don't know how we're supposed to check this answer. So the answer would be just leave it as 122 over 7, or about 17.4. It probably should have worked out. Not the best example because it didn't work out nicely. Usually it will work out. And this question says solve and check. You would never, never, never have to check if the answer didn't work out. It would be beyond this course. Yes? On the exam, a question like that would happen, but I think it would work out. That being said, if you look at all those steps. If you do all those steps and you get a decimal on the exam, leave it and move on. Don't stop and go, oh, I have to find my mistake. It's wasting time. Leave your answer because it's possible that it's correct. There's no reason, it's not impossible that answers work out to fractions or decimals. That is something that happened throughout this course. You wouldn't be asked to check that in that case. But also, it's better to finish the rest of the exam and come back and try to find your mistake later. Okay, any questions?